Hi, in this video we will discuss the model of costs. Because the model of costs is built on the model of production functions, so we will take a similar framework to think through two different scenarios. Short-run costs, where one input cannot be adjusted, and the long-run costs, where all inputs can vary. But before we go into the details, let's first summarize the few different types of costs frequently mentioned in economics analysis. Firms minimize their costs all the time. They use all types of technology to cut costs. They adopt new and more efficient tools, such as robots and automation. They outsource jobs to other firms and to other countries to save labor costs. Costs are an essential part of any firm's decision-making process. In economics, we refer to different types of costs. There are operating costs that firms incur when producing goods and services. There are opportunity costs, which are the foregone benefit when the firm chooses one option over the other. And there are sunk costs, the costs that were incurred previously before the decision is made. In our model, we will only explicitly model the operating costs. The opportunity costs and sunk costs will come out of the models naturally once we take into account the timing of decisions. We will see this point in the next section. Now let's delve into the short-run costs, where some inputs are fixed. Because some inputs are fixed in the short run, their costs don't really change. Using our previous example about UPS, in the short run, they cannot change the number or the sizes of their warehouses. In that case, all costs related to the warehouses are fixed. It does not vary if UPS delivers millions of packages or just hundreds of them. On the other hand, because UPS can adjust the number of warehouse workers they hire based on the seasonality, their labor costs will likely vary with their business. During the holiday season, when they deliver more packages, they can hire seasonal workers and their labor costs are going to be higher. We can generalize this idea by separating firms' costs into fixed costs and variable costs. Fixed costs are those that do not vary with the level of output, because their underlying inputs are fixed in the short run. And variable costs are those costs that vary with the level of output. Put in technical terms, the fixed cost is a constant with respect to the output level Q, while the variable cost is a function of Q. Taking this perspective, the total cost of the firm can be broken down to the variable cost part and the fixed cost part. And the marginal cost of the firm to produce the next unit of output is just the derivative of the total cost with respect to the output level. But by the definition of the fixed cost, it does not vary with the output level Q. So the derivative of C with respect to Q is the same as the derivative of variable cost with respect to Q, because the derivative of F with respect to Q is just 0. In addition to the marginal cost, we can also calculate the average cost of each unit of output by dividing the total cost by the output level. With the total cost broken down into variable cost and fixed cost, the average cost is just the average variable cost plus the average fixed cost, which are just variable cost divided by Q and fixed cost divided by Q, respectively. Now let's look at a specific example to understand these concepts a little bit better. Let's say that we have a cost function that looks like this. What are the fixed costs, the variable costs, the marginal cost, and the average cost of this firm? Can you pause the video here and think about it for a little bit? Well, the fixed cost is the part in the cost that does not vary with the output level. So in this cost function, the first three terms all vary with the output level. Only the last term here remains a constant, regardless of what Q level is. So it is the fixed cost. And therefore, for the same reason, the variable cost are just these three first terms that changes with Q. What about the marginal cost? Well, to find the marginal cost, we just take a derivative of the cost function with respect to Q. Notice that the fixed cost part just drops out, again, because the derivative with respect to Q is 0. So the marginal cost is the same as taking derivative of the variable cost with respect to Q, and it will give us this expression. This is why we don't mention marginal variable cost at all, because it is always the same as the marginal cost itself. We can also calculate the average cost of the firm by dividing the total cost by the output level of Q. And it is the same as dividing the variable cost by Q first, and then add it to the fixed cost divided by Q, which is our average fixed cost. These two graphs on the right-hand side illustrate these objects graphically. In the top panel of this graph on the right-hand side, the green curve plots the total cost function, which is here. The purple curve plots the variable cost function, which is the three terms. And the flat yellow curve plots the fixed cost, which is just 450. On the bottom panel, the graph plots the corresponding marginal cost curve and the average cost curves, with the output level lined up with the top graph here. Now let's take a look at these two graphs more closely to understand their properties a little bit better. Here on the slide, I just put the same graphs on the left-hand side. First, note that the gap between the total cost and the variable cost curve are always the same, and it is exactly the height of the fixed cost curve. This is because by the definition of these costs, the total cost is just the sum of the variable cost and the fixed cost. So graphically, we can think of just grab this variable cost curve and then raise it up by the height of the fixed cost. So graphically, we can think of it as taking this variable cost curve and then just raise it up by this constant height of the fixed cost curve to get our total cost curve. Also because of this, the variable cost and the total cost curves are exactly the same shape. This means that these two curves have exactly the same slope at each and every output level. In other words, marginal cost, which is the slope on the total cost curve, is exactly the same as marginal variable cost, which is the slope on the variable cost curve. It is also worth noting that the average fixed cost is always decreasing in the output level, because the fixed cost does not vary when the output level increases. So as Q goes higher and higher, the same fixed cost is being divided among a bigger base of outputs. So the share of fixed costs for each unit of output gets smaller and smaller as Q increases. And now let's take a closer look at how the marginal cost changes with Q in this graph. If we start off from a low level of Q and raises it gradually, then we can keep track of the slope of either the variable cost curve or the total cost curve. We'll see that on this graph, the curve doesn't start off very steep. But if you look closely, you will notice that actually it becomes a little bit flatter as Q increases, and then becomes steeper and steeper and steeper as Q gets higher and higher and higher. In other words, overall, the marginal cost increases as Q increases. We can also see the same idea reflected on the lower panel here, where the marginal cost is plotted by this red curve. It may decrease initially when Q is low, but once Q is sufficiently high, the marginal cost will increase faster and faster and faster. This is a very common feature of cost functions. The reason lies in the decreasing marginal returns in the short-run production function. Once the firm reaches a very high output level, to further push up the output, the firm needs to put in more and more inputs for the next unit of output. As a result, the marginal cost rises faster and faster as the output level increases. Now let's try to look at the average cost and the average variable cost. Let me zoom into the top graph again. Recall that from the marginal and average product curves, we discussed that the value of the average is measured by the slope of the ray from the origin connecting to the corresponding point along the total curve. Now, if I draw a ray from the origin and start to point towards different points along this variable cost curve, we will see that the ray initially slowly decreases in its slope and then overlaps with the tangent line at point B here. And then once we pass point B, the slope of the ray starts to grow higher and higher and higher, but it won't be as steep as the marginal costs. We can see the same relationship plotted in a different way on the lower panel graph. The same relationship between the marginal cost and the average cost reappears here. The average variable cost initially decreases when the marginal cost is below the average variable cost, and then increases when the marginal cost becomes higher. But unlike the marginal product and the average product case that we discussed previously, the marginal cost is lower than the average variable cost when Q is low. So the average variable cost curve dips down initially and then reaches this trough when they're equal to each other at this point, instead of a peak in the marginal product case. After the trough at point B, the marginal cost gets higher and higher, and the average variable cost curve is dragged up with it. A very similar case goes for the average cost as well, if we look at the slope of the ray pointing to different points along this total cost curve. I'll point out two differences here. First, the average cost is clearly higher than the marginal cost initially and becomes equal to the marginal cost at a higher output level, or point A here. And then it goes up from here, but no longer as steep as the tangent line, which is the marginal cost. The second difference is that the average cost is always higher than the average variable cost at any given output level. We see that for the same output level of Q equal to 10 here, we draw these two rays pointing to the corresponding points along the total cost curve and the variable cost curve. The ray pointing to the total cost curve is always steeper than the ray pointing to the variable cost curve. This difference holds true for all output levels. The average cost is always higher than the average variable cost, but their difference becomes smaller as Q increases. These two observations are also reflected in the lower panel here. The average cost curve, which is plotted in green, decreases when the marginal cost is lower than that, and it increases once the marginal cost becomes higher than the average cost. So it reaches this trough when the average cost and marginal cost curves crosses at its trough at this point little a here. One way to describe this relationship in the principles class is that the marginal costs cuts the average cost curves from below at their lowest points. But the underlying reason is that the relationship between the average and marginal values, just as we discussed when we talked about marginal product and average products. The last note I would like to make about this graph is that the gap between the green average cost curve and the purple average variable cost curve becomes smaller and smaller as Q increases. This is because their gap is exactly the average fixed cost. And as we just discussed above, as Q increases, the average fixed cost becomes smaller and smaller, so the difference between the two average costs just becomes smaller and smaller. In the next video, we will turn to the discussion of long run costs and how they relate to the short run costs.